calculus applications. We can use calculus to find the maximum and minimum values, or the stationary points, or the turning points of a given curve. So this curve over here is the minimum curve, and this is the minimum point, and at that point the tangent is horizontal, meaning that the dy dx, which is the gradient over there, is equal to 0. The same thing applies here. Now, to determine whether the curve is a minimum or maximum curve, we take the second derivative. So if the second derivative, after substituting the x value over here, is greater than 0, then that curve is a minimum curve, or it is concave upwards. And also, if you substitute the second derivative into the second derivative and it is less than 0, then that curve is a maximum curve. We can also use calculus to find the area under the curve, that is integration. So we know this is a triangle, and the area under this curve can be found using the area half base times height. The base is 4 units and the height is 4 units. This is given as 8 square units. We find the definite integral from 0 to 4. We are also going to get something like this, which will give us 8 square units. So it's telling us that the integral, the definite integral, will give us the area under the curve when we take the absolute value. Now let's take some passive past questions on that. Find the maximum and minimum points of the curve. So as usual, we find dy dx. So dy dx over here will be equal to, this will give us 6x squared then minus 6x and this will give us minus 12. So at turning points, the dy dx is equal to 0. So it means we can reduce this. At turning point, dy dx is equal to 0, meaning that we have 0 is equal to 6x squared minus 6x minus 12. Now we can break this down to obtain x squared. Dividing through by 6, we have x squared minus x minus 2 is equal to 0. So we have either x is equal to, when you solve this, you're going to get x either x equal to -1 or x is equal to 2. Okay, now we use these values to find the corresponding y values over here. So when x equal -1, so when x equal -1, when x equal -1, y will be equal to 2 times -1 cube, then minus 3 times -1 squared, minus 12 times -1, then plus 4. Then this will be equal to 11. So we have one of the points to be -1, -1, 11. Now when x equal 2, we sub in x equal 2 into this function again over here. So when x equal to 2, we are going to get y to be equal to -60. When you sub in 2 into this, you are going to get y to be equal to -60. So another point, another turning point is 2 and negative 16. Now we are going to determine whether this is a minimum turning point or not, or this is a minimum turning point or not. So what we do is to find the second derivative, which is d2y d2 is d2y dx squared. So this will be equal to, so we continue from here. So it will be equal to 12x d2y x squared. We differentiate this again. We have 12x minus 6. Now when substitute negative 1 into this, we are going to get, so at x equal negative 1, we are going to get d2y over dx squared over the s squared to be equal to, now we have 12 times negative 1 minus 6, and this will be equal to negative 18. Now negative 18 is less than 0, so it means the curve is concaved downwards over here. The curve is concave downwards. If the curve is concave downwards, it's going to have a maximum turning point. So a maximum turning point. So this turning point is a maximum turning point. That is negative 111 is a maximum turning point. Then the minimum turning point is 2 negative 16. So we can use the same approach to over there. We substitute in 2 into this. You realize that it is greater than 0. Then we have this one. Find the area enclosed by the x-axis and the curve y equal 3x squared plus 2x minus 1. Now to do this, you see they said the curve enclosed by the x-axis and the curve y equal 3x squared plus 2x minus 1. So we find where the curve meet the x-axis. When the curve meet the x-axis, at that point y will be equal to 0. So y will be equal to 0 whenever the curve meets the x-axis. So we equate this to 0, meaning that we have 0 is equal to 3x squared. 0 equal 3x squared plus 2x minus 1. Now we factor this to obtain 3x minus 1 into bracket x the bracket x plus 2 x plus 1 bracket x plus 1 is equal to 0. So we have 3x minus 1 x plus 1. So this implies that our x is equal to negative 1, x is equal to negative 1, or x is equal to 1 over 3. So these are going to be the boundaries of integration for us. So the area under this curve is going to be from, you're going to get integral from negative 1 to 1 over 3, negative 1 to 1 over 3 of the curve 3x squared plus 2x minus 1 dx minus 1 dx. Now integrate this to obtain, if you integrate this, you're going to get 3x. So 3x, we're going to get 3x cubed divided by 3 plus 2x squared over 2 then minus x. Then we are going to integrate from 1 over 3 or from negative 1 to 1 over 3. We can simplify this further to obtain. So instead of being 1 over 3 here, you're going to get 1 over 3 cube, 1 over 3 cube over here, then plus 1 over 3 squared minus 1 over 3, then minus, we have negative 1 cube plus negative 1 squared, then minus negative 1. Now this will give us 1 over 27 plus 1 over 9, then minus 1 over 3, then we're going to get minus 1. Now when you simplify all this, you are going to get 22 over 27. So note that this will give us negative value, but we need to take the absolute value. So this was actually negative 22 over 27, but the area is an absolute value of the result, which will give us this value over here.